Thrubia. I'm a BTech Mechanical Engineering graduate. My passion lies in teaching, and my other interests include music and art. The topic that I've chosen to teach in this lesson is structure of an atom, and here I begin. Coming to the fundamental building blocks of matter, we've studied that it is molecules in earlier classes and about the molecular arrangement in various states of matter, such as in solid, liquid, and gas. The tight arrangement in solid, the looser arrangement in liquids, and the very loosely arranged in gases. But what are molecules made of? Molecules are made of particles called atoms. That is, a group of atoms put together form these molecules. But what are atoms further made of? Before I answer this question, let me quickly take you through a story of wherein physicists and chemists perform various experiments in order to, propose different models of the same atom. So, starting with Sir J.J. Thomson, Sir J.J. Thomson proposed the, plum pudding model, or which is famously known as the watermelon model of an atom. So he perceived the atom to be a ball of positive sphere wherein the electrons were arranged on it. But Sir Ernst Rutherford further came up with his own model wherein he conducted the famous gold foil experiment. So this particular experiment he conducted with the help of an alpha particle source wherein particles which were positively charged were emitted in order to hit a gold foil. So his observations were one in every 20,000 particles got deflected, and the rest of all the particles got to get through the screen. So this particular thing was recorded with the help of a detecting screen. From there, and with the behavior of charged particles, he came to a conclusion that there's something which is going to be carrying a net positive charge that is present in the center, around which electrons are going to be revolving in an atom. And moving further, Sir Niels Bohr came to a conclusion that electrons are going to be revolving around the positively charged nucleus, just like how the planets revolved around the sun, and in separate discrete energy levels called orbits or shells. So they he named it as energy levels. They're also called orbits or shells. So these imaginary orbits or shells are the pathway in which these electrons are going to be revolving around the positively charged nucleus in an atom. And also remember, there is going to be something called the neutrons, which carry no charge, but they do have a mass. And there are going to be subatomic particles called as protons and electrons, which carry a net positive and a net negative charge, respectively. So the neutrons and the protons together form the nucleus, which is going to be present at the center, and the electrons, which are negatively charged, revolve around this nucleus in discrete energy levels. Although he was able to give an explanation of the model, there were drawbacks in this particular model, as according to energy conservation of energy. So anything which is going to be revolving should eventually lose energy and should collide at the center, but he failed to give an explanation for this particular limitation or drawback. And moving on to say the distribution of electrons, or how electrons are going to be distributed in the various energy levels or shells. So he gave a formula which is known to be 2n squared. The naming that he gave was it began from K, L, M, N, and so on, the English alphabets. Or he gave numbers such as 1, 2, 3, and so on. So these particular numbers, they meant shell number 1, shell number 2, and so on. So he gave the formula which was 2n squared in order to better understand the distribution of electrons. So let us consider the K shell, which is the first shell. So I will be substituting n as 1 in order to get 2 into 1 squared, which will give me 2. And in the second shell, which is say the L shell, the number of the shell is 2, and I will be substituting in that formula to get 2 into 2 squared itself, which is 8. And in the M shell, I get 2 into 3 squared, say, which is 2 into 9, that gives me 18. And N shell, 2 into 4 squared, which gives me 32, and so on.